My name is Alyssa Cisneros, and today I'm going to be showing you my poster. I did the brochure template here on Google Docs. It is multiple pages, however, I just had so much information to share with y'all. So let's get started. So today we will be examining surface chlorophyll over time in the ocean within the temperate zone. These are the areas of the temperate zones. It is the Endurance Arrays in the North Pacific Ocean, the Pioneer Array in the North Atlantic Ocean, and the Argentine Basin Array in South Atlantic Ocean. I also provided a graph on what the topic is on. Now, the introduction is what's going to give us the scientific background information. Methods will include the data description, my assigned zone, along with the stationed arrays. Results will have questions 1 through 4 summarized, and the last section is discussion and conclusion, which will have 5 and 6 summarized along with a remaining conclusion and or question. Now, research is not always conclusive, which is why I added a question, because there's always going to be more questions adding up. So, let's get started. So throughout the 5-week course of oceanography, you and I have both learned so many things. We've learned about ocean currents and erosion of sediments. I have got to look at a graph and data analysis to find out what is the relationship between primary production and geography. The poster is to gather all information that I have learned and put it into practice, which is what this course project is used for actually. So the graph displayed here is the graph of temperate zones and surface chlorophyll over time. The locations are the Endurance Array in the North Pacific Ocean, Pioneer Array in the North Atlantic Ocean, and the Argentine Basin Array in the South Atlantic Ocean. Those are my temperate zones once again. The graph is displayed here in blue. There's the North Pacific, aka the Endurance Array, the North Atlantic, which is the Pioneer Array, and the green is going to be South Atlantic, which is the Argentine Basin Array. The patterns Okay, how to get my document all circled up here. So the patterns that I have noticed is in July of 2015 was the highest of chlorophyll concentration with a high of 30 in the North Pacific, and the lowest was near January 2016 with a close number of 0. For the North Atlantic, the high was near April 2015 with a high of 11, and the lowest was near May of 2015 to January 2016 with a low score of 0. And then lastly, the South Atlantic has a high of 5 near April 2015, and from May 2015 to October 2015 was the lowest of 0 chlorophyll concentration. High numbers of chlorophyll means more presence of phytoplankton. According to the data on the graph, spring is when primary productivity is highest in phytoplankton. Fall to winter is when primary productivity in phytoplankton is lowest. As we can see, the Endurance Array, which is the North Pacific, had the highest surface chlorophyll concentration than the Pioneer Array, which is the North Atlantic, and the Argentine Basin Array, which is the South Atlantic. So let's go back and look at this graph, and let's see if I was right. As we can see, the blue in the North Pacific, which is the Endurance Array, we can see it has very high levels of chlorophyll concentration. But once again, it starts to go down here in end of July towards October of 2015 and continues to be low towards January of 2016. Let's continue. Both the North Atlantic and South Atlantic had low scores of surface chlorophyll. However, in Argentine Basin Array, which is the South Atlantic, there was a high of 4 in April of 2015, and the Pioneer Array had the high of 11 near April 2015. So both decreased near July of 2015. The conclusion that I have drawn to is that North Pacific, there are warmer springs. The North Atlantic and South Atlantic have cold springs and slightly warmer winters. Because of the warm springs, North Pacific productivity in phytoplankton is high. Another pattern I recognized is the Pioneer Ray, which is the North Atlantic. There was a weird spike in May 2015 with the high of 10 in surface chlorophyll. The warmest month in North Atlantic region is May through July. My hypothesis is since it got warmer during that particular month, the chlorophyll concentration spiked up. Geographical variation in primary production as well as biology production of higher levels is closely related to surface current systems. So let's look at that weird pattern that I have noticed. So we said in the North Atlantic there was a weird spike. Do y'all see that? The weird spike near 10, near of April? That is the weird spike that I have noticed, and I just wanted to let y'all know what other patterns I have noticed and not just a common pattern such as the North Pacific, because we can obviously see that. However, I just wanted to discuss that North Atlantic pattern. Okay, low chlorophyll means less phytoplankton, which means more CO2 will stay in the atmosphere instead of being dissolved in the ocean. Well, what does that mean? I'm so glad you asked. So, phytoplankton, right, generates about half of the atmosphere's oxygen, as much as per year as all land plants. They make other ocean life possible. So less phytoplankton is very bad for us because that means less oxygen throughout the earth, which also means other ocean life could not be possible without phytoplankton. Now, I've also wanted to raise the question of, is there a bad thing as too much phytoplankton? And there is, so we will go more deeply into that. High levels of chlorophyll means an increase in phytoplankton. However, when there are too many nutrients that are available, phytoplankton may grow out of control and form harmful algal blooms or HABs. These blooms can produce extremely toxic compounds that have harmful effects on fish, mammals, birds, and even people. So we have to have a happy medium here, as we can see. So low amounts of chlorophyll means a decrease in phytoplankton, which means a decrease in oxygen. And high amounts of chlorophyll means a high increase of phytoplankton. Now, if there's too much phytoplankton, these can form harmful blooms. These harmful blooms can really affect just about anything, which, as we stated, includes fish, mammals, birds, and even people. So even if we consume it, it's going to be bad for us. Now, there was one question that was still remaining, and I'm going to discuss on that a little bit. So, as we just stated in the beginning, we've learned about ocean currents. And I think it was in week 2 or 3. I cannot remember. So, my question is, how would the ocean currents be relevant to chlorophyll A concentration levels? And these are my citations. Have a wonderful weekend.